Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on December 22, 2025, about 5 days ago. It introduces VA-Pi, a lightweight post-training method that directly aligns an autoregressive image generator with pixel space quality, and it cuts FID from 14.36 to 7.65, while boosting inception score from 86.55 to 116.70 on Llama Gen XXL, using only 1% of image net 1K and about 25 minutes of tuning. The paper is titled VA-Pi, Variational Policy Alignment for Pixel-Aware Autoregressive Generation. Okay, and as we will see later, the core idea of using a variational objective plus reinforcement learning style rewards makes the improvements feel surprisingly practical. Also, the authors shared an implementation on GitHub, and it is pretty practical. You will find code organized around LlamaGen and Janus Pro, setup instructions, and scripts for post-training VA-Pi on C2I and T2I. The repo also includes sampling and evaluation workflows for FID and Genival. Figure 1 makes the payoff concrete because it links better-looking samples with a measurable shift toward real image structure. This figure shows a goldfish comparison, with the base Llama Gen XXL on the left and VA-Pi on the right. The bottom left plot uses kernel density estimation, which means a smoothed density map to show aligned outputs moving closer to the ground truth cluster. The bottom right t-SNE embedding plot shows the same idea, with aligned points sitting nearer ground truth. Figure 2 explains why VA-Pi can improve image quality without retraining the tokenizer, because it creates a pixel-based reward signal for the autoregressive generator. The full pipeline starts from a reference image, which gets encoded into discrete tokens by an encoder plus quantizer, meaning it compresses pixels into a codebook of symbol IDs. The autoregressive model then predicts logits under teacher forcing and samples candidate tokens. Those tokens get decoded back to images, and the reconstruction reward plus next token regularization guides the policy update so the token distribution stays sane. Table 1 shows that pixel space alignment can also improve text-to-image matching, even without training on an external reward model. The full table compares 3 rows for Llama Gen XL, where external reward is marked as present or absent. The key takeaway is that VA-Pi still scores higher on clip score, which is a similarity score between the image and the text prompt. The same pattern holds for HPS version 2, so the gains are not just one metric. Table 2 puts hard numbers behind the claim that pixel space aligned tuning boosts quality without big compute. This table reports ImageNet 1K results for Llama Gen XL and Llama Gen XXL, with and without classifier-free guidance, which means mixing conditional and unconditional predictions to steer samples. In the Llama Gen XXL block, VA-Pi reaches about 7.65 FIDence without guidance, and about 2.28 FIDence. The same rows also show a much shorter tuning time than other post-training baselines. Alright, 2 takeaways stand out. VA-Pi fixes the core mismatch between token likelihood training and pixel quality by adding a pixel space reconstruction reward, and it does it as fast post-training without retraining the tokenizer or adding an external reward model. The broader implication is that more generative models can get reliable quality gains with minimal data and compute. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.